address flagship projects from across Europe. So we have some wonderful speakers, but first I've got a few items of housekeeping I've been asked to repeat. So again, there's a policy of no filming or photography from delegates throughout this conference. You've seen our lovely photographers wandering around, so please go to the gallery. That will be available afterwards if you want to share photos. Where the presenters are using PowerPoint slides and we have permission, these will be loaded onto the session app afterwards. And then we'll take all of the questions at the end, where we hope to have at least 15 minutes for questions, both from the audience. So today we've got 3 speakers in this session. First of all, we have Sverre Overa, who is the project director for the Northern Lights project. Then we'll be hearing from Filip Neele from TNO. Then finally, we'll be joined virtually by Winston Beck from Heidelberg Materials. So first of all, just a sentence on our first speaker. Sverre has worked at Equinor since 1984. From 2016 to 2021, he led the Northern Lights project on behalf of the partnership Equinor, Shell and Total. And he now leads the project in Equinor on behalf of the newly started company, the Northern Lights JV-DA. So Sverre, please come and give your presentation. Thank you.
Thank you, and thanks for being welcoming me here this afternoon. Actually, it's past 12, I guess. So there's been a lot of talk. I've been listening in this morning on the things that we need to do. Northern Lights is actually where we're doing it. So there's a difference. I'm going to talk about what we're actually doing with respect to transport and storage. Northern Lights is a real project. You see on the slide behind me, you see an artist rendition of what it will look like, the receiving terminal outside of Bergen on the west coast of Norway when it's finished in about 1.5 years. And then you see a photo taken a few weeks ago on one of the sunny days, what it looks like at the moment. So we're about 65% complete with respect to the construction activities. And we're on track to be ready to start receiving CO2 coming in by ships in the middle of 2024. So that's kind of the framing. But if we go one step back, Northern Lights is part of the Norwegian government's Longship, which is an initiative to enable CCS as a full value chain. The Norwegian government recognized that it won't happen by itself. You won't get emitters to install capture without having transport and storage in place, and you can't really get transport and storage getting started without having emissions to handle. So you need both players in there for this to work. So Longship includes emitters, and there are 2 of them. One is a cement factory in Norway. Cement has already been mentioned earlier as one key industry that needs essentially CCS. The other one, which hasn't been mentioned as I have heard at least, is a waste to energy plant in Oslo, Celsio. Again, waste to energy do not really have any other means of reducing their emissions except CCS. They can't go renewable, obviously. The total Longship project is a fairly extensive initiative. Apologies for using dollars here. I guess that equates to pounds these days. So anyway, we're talking about 3 billion pounds initiative, of which the government is actually funding 80%. So there's a significant contribution from the state to make this happen. The remaining 20% is covered by the industries that are involved. And this is the initial phase, building the infrastructure. The scale-up that will happen, especially on the transport and storage side, needs funding from the industry itself. Northern Lights is part of a PCI. We're running a PCI. And under that PCI, we've actually secured CEF funding from the EU to start the studies necessary to implement scale-up. So that's actually also happening. And then just a few words on what Northern Lights includes. Obviously, there's ships needed for this transport. And then there is a receiving facility, the one that you saw the photo of. The receiving facility will be, in addition to the ships, the only visible part of what we're doing once we're finished. And it has obviously a jetty suitable for receiving ships of the size that we're currently constructing, but also larger ships will be able to utilize this jetty. It has a very simple process plant. Actually, it's only an intermediate storage, allowing us to empty the ships quickly, for them to pump it out at a reasonably regular rate into storage. So the tankage is only there as an intermediate measure to allow quick turnaround of the ships. And then, of course, what we have is the offshore scope. Because this is the key part, and it's the majority of the cost actually, and it will always be invisible for you afterwards, because it's underwater. There is a pipeline going out. It's about 110 kilometers out to the site that we have. We have secured a license for a fairly large area to be used for CO2 storage. It's the first such license that was offered. And I know that you have similar licensing in the UK, but we were the first, at least in Norway, for that. And we also have installed the necessary control cables and so on for this to take place. The illustration that you see there are essentially the pipe segments and the subsea structures that we install. Then, of course, we have the storage itself. It's a saline aquifer. We have drilled 2 wells. The first one 2 years ago to confirm suitability. The second one we drilled just a few weeks ago, completed that. And it confirmed that what we thought, that we have a very large suitable reservoir that can take significant volumes for permanent storage. And with that, just a photo here showing where we are at. We have a site being developed. The equipment is fabricated. Most of it is actually ready and is starting to be shipped to the site and to the yard where we're assembling things. The subsea equipment is either installed or in Norway, ready to be installed. We have a campaign ongoing and ships on the water as we speak. And at the bottom, on your right, I guess it is, or is it your left? Yes, your left. You will see what we call the visitor center, which was opened yesterday by the Norwegian Prime Minister, and it's built essentially to accommodate visitors to show what we're doing and to talk about it like we do here today. And if you have the opportunity to travel to Norway, you're quite welcome to come visit us there.
Thank you very much. So our next speaker is Filip Neele. So Filip coordinates the CO2 capture, transport and storage research that is performed within TNO. He has coordinated the contributions from TNO to the development of the Porthos CCS project, and he is co-chair of the Zero Emissions Platform Task Force Technology, covering the area of CO2 transport and storage. So thank you for helping me welcome him to give his presentation.
Thank you, and thank you for inviting me to speak here at this event. I find it really very interesting to see all the people here, and it's noticeable that there is momentum again in CCS, so that's really good. For those of you perhaps not familiar with TNO, we are the largest R&D organization in the Netherlands. We cover a lot of areas. and one of them is the subsurface and the deep subsurface. And this is obviously what I'm going to talk about. As mentioned, we've been involved in the CCS projects in the Netherlands about 10 years ago. We did subsurface study work for the road project, which resulted in the first CO2 storage permit issued under the CCS directive. And more recently, we've done the same thing for Portas project. Now, what I'm going to talk about in the few slides that I have is the proving up of storage to become online. I have an illustration here that's quite old, I think, but that nicely shows the different elements that we have to think about when storing CO2 in the subsurface. So this can either be a depleted oil or gas field or saltwater filled structures, aquifers, and they each have their pros and cons, but in both cases we are dealing with, as is shown in the illustration, with very familiar elements. We have wells, we have faults, we have caprock, we may have spill points, and this is all really good stuff. In the storage area, if you like, we know those things and industry knows how to deal with them. Moving on, I have a map here that's taken from the Zero Emissions Platform website that shows currently active projects in various stages of development. And what I want to highlight here with the map is that there are indeed many projects being developed. Storage in the North Sea, it's been mentioned yesterday, tens of gigatons is on this slide, perhaps it's even hundreds of gigatons of capacity, so that's not the problem. What I wanted to highlight with this slide also is that CO2 storage is something we can do. We have about 40 megaton per annum of storage rate worldwide. Over 200 megaton has been stored so far. And the important message there is that there is no sign of any leakage so far. So this really is something we can do. It is available technology, perhaps not how do you say, familiar technology for all the countries in the map here, but it's something that can be done and that industry has proven it can do. Also on this slide is a remark on the timeline to developing storage, which also has been mentioned in this event. 5 to 7 years for depleted fields. I think that's realistic, if a little bit ambitious for today's projects. But for aquifer developments, aquifer storage, it will be a couple of years longer. I'll come back to that. And then finally, transport is also something we can do. So what does a storage project look like? Schematically, it looks like this. We have an emitter over on the left, feeding into a collection network usually. The CO2 is compressed to go into usually an offshore high-pressure pipeline, where it arrives at the platform to be injected into one or more wells into the subsurface. On this slide is a number of how do you say, issues, processes that need to be taken into account while designing the storage project in such a way that during the lifetime of injection, there will always be safe conditions in the entire system. In some cases, especially for depleted oil fields, it is quite a challenge, I think, to come up with a way to safely operate a store. But again, going back to the map I just showed and to the slide before that talking about the number of projects worldwide, this is something that industry can do. Projects developing especially depleted field storage are now have already handed in permit applications to store CO2. And that's a sort of a reality check that this is indeed a technology that is on the shelf, perhaps is a good phrase. On my next slide, this is a schematic of the timeline from idea to operational project. It's not meant to be exactly like this in practice, but it's to give you an idea. The top half of the illustration is the time in which the operator develops and designs the project and works towards handing in a permit application. Also, the environmental impact assessment is done in that period, and that typically takes 2, perhaps 3 years. Then permits are approved in place. That's the time that an investment decision can be taken and construction can start. Yesterday it was mentioned that the second part of the lower half of this illustration, the construction part of projects, is actually quite difficult to make faster, to decrease in duration. What I think could be done to compress the long lead time of storage is to smoothen or make more easy the first half of this period, the working towards a permit application. When I talk to regulators and operators, future operators of fields, I often hear that there is a lack of clarity about the target for their permit application. There is lots of detail in the storage, in the CCS directive, but when you sit down and try to do the work and look at the risks, it isn't clear when you should stop. Do you write 2,000 pages? Do you write 3,000 pages? Both on the regulator side and on the operator side, I think there is some unclarity there as to what is needed in order to get a permit to store. So for now, my single recommendation, and this is going to be my last slide, is to look at whether the process of writing permits applications can be made more efficient. And I think there could be a need. One of the ways out could be to define clear targets, performance targets for storage projects. And if you break it down a little bit, performance targets for monitoring and the operational plan. I'm sure we'll get back to that. And with this, thank you for your attention.
Thank you. Now I'd like to introduce our third and final speaker for this section, who will be Winston Beck, who is joining us virtually. Winston is the Head of Government Affairs at Heidelberg Materials. He heads up the Brussels Liaison Office at Heidelberg Materials, which is one of the world's largest construction materials companies, and he actively engages with political, industrial and societal stakeholders on the main EU and global policy issues. And hopefully by the magic of the internet, he will now appear.
Hello everyone, can you hear me? Hello, can you hear me? Ah, perfect, okay, I can. All right, so first of all, thanks very much for the invitation, and apologies that I could not join in person. But it's great that I have at least the opportunity to connect virtually, and I had also the chance to listen some of the very inspiring presentations and discussions already today. So I've been asked to give a very brief overview of our CCUS developments. Maybe very briefly, to Heidelberg Materials, for those who don't know us. On the next slide, you will see a brief overview. Formerly known as Heidelberg Cement, we are indeed one of the largest global providers of construction materials. First and foremost, cement and aggregates. which are the two main ingredients to produce concrete, but we are also in the ready mixed and in the asphalt business. And concrete is a product that is in very high demand. It is actually the second most used material in the world after water, and of course critical to construct infrastructure as well as housing. So it really provides a significant value for society. But at the same time, cement production also comes with a large CO2 footprint. And that is why we as Heidelberg Materials really want to show leadership in driving the transformation of our sector. On the next slide, you will see that we aim to reduce our CO2 footprint by almost 50% by 2030 and to become net zero by 2050. For 2030, that means that we need to further reduce our emissions by around 30% compared to 2021. And that is, of course, a huge ambition, and we really must use of all technologies and solutions there are in order to achieve these targets. And people familiar with the cement production, they will know that we have a high amount of unavoidable process emissions, which means that we really rely on deploying large-scale CCUS as soon as possible. And this is also why we have made the public commitment to already remove 10 million tons of CO2 through CCUS by 2030. And we are not just talking the talk, we are also really progressing on the target. And on the next slide, you will see a picture of our plant in Brevik, Norway, where we are currently constructing the first large-scale industrial CCS plant in the cement industry for 2024. Sverre already alluded to it. We aim to capture 400,000 tons per year, which is around half of the plant's emissions. And the CO2 will then be captured and transported to Northern Lights, as explained previously. And the project is actually also supported by the Norwegian government, and it's really fantastic to see such a commitment in Norway. But this is really only the beginning for us. On the next slide, you will see a map where we have highlighted our most advanced projects in the group. So that's really the top of the pyramid of all of our CCUS projects. I will not go through them in detail, but since the conference is held in London, maybe I should at least allude to our CCS project in Padeswood, where we are planning to capture and store 800 million tons of CO2 by 2028 at the latest. And that is actually connected to the HyNet low carbon hydrogen project, which is close to Liverpool. In Sweden, we also have a project at our Slite plant on the island of Gotland, which is our biggest CCS project in Europe, where we aim to capture 1.8 million tons of CO2 by 2030. And finally, we are quite pleased to say that we are now also part of the EU's Innovation Fund with our CCUS project in Bulgaria. This is actually quite an exciting one because it is a single source and storage project for our Defnia plant in Varna. And it is the first full CCS value chain in Eastern Europe, where we will make use of a depleted gas field under the Black Sea. So really, we are developing CCUS projects across Europe. And of course, we are quite confident that we can take care of the carbon capture element, but we need really to work with our partners together because none of these projects can be done alone. And in particular, when it comes to transporting the CO2 from the plants to the storage or the use application. And that should be ideally in the form of pipelines, as this is the lowest cost option. But of course, we will also make use of ships and rail. And on the next slide, you can see that there has been really some promising news lately. These are some of the public announcements which have been made in the last months and weeks. So there are pipelines being planned to connect, for example, Belgium and Norway to the North Sea. And very importantly, there are also projects appearing which aim to connect the major industrial hubs to these ports. For example, North Rhine-Westphalia, where we have a lot of cement, lime, and chemical industry clusters, which will then be connected to either Rotterdam in the Netherlands or to Westhaven in Germany. But at the same time, I think it's very important that already now we also start to think about the more remote plants, especially for the cement sector, which is quite a local business. We have a lot of plants which are not close to these industrial hubs. So we already need to start thinking about pipeline backbones or how to connect them with inland water shipping, for example. And also, I mean, we are talking a lot about the North Sea, and that is really where all the experience and a lot of the exciting projects are. But we also need to think how we can use this knowledge and mirror it in other parts of Europe, including Eastern Europe and the South. Now, I will conclude with my last slide with some recommendations. I may not go through them in detail. I also cannot read them from here, but maybe to highlight 3 main points. I think, as the conference title says, it's time to deliver. I mean, 2030 is only 7 years away, so I agree with some of the previous speakers that we really need also, besides the commitment from the industry, that we also need a clear political commitment for CCUS as one of the main technologies to decarbonize process industries. And this includes, of course, also the necessary regulation and funding to roll out these projects. And I agree with what Filip has just said before, but we also need very clear criteria for the permitting and as well as for the funding. And as mentioned before, we of course also should accelerate the rollout of transport and as well as storage infrastructure, starting with the hubs, but also thinking about our remote plants. And last but not least, and this is part of this conference, I also think that we really need to engage in more dialogue between all the stakeholders. That should also include the society overall, as we really need to increase acceptance for these projects. But it also includes having more discussions between the national regulators. I mean, we see that there is a lot of knowledge and experience now around the countries around the North Sea. And that knowledge and experience should also be brought to other national regulators in areas which are maybe further away from that area. Thank you.
Thank you, Winston. So we now have about 9 minutes before lunch in which to ask our questions. So we've got 2 people going around with microphones. So if anyone has any questions, we've got one here at the front. We'll take one at a time because I can't remember more than one at a time. Sorry.
Hi, Sebastian Dodd, Carbon Clean. In America, there's been a lot of pushback about the proposed pipelines across the Midwest. Is that an issue that you encountered when setting up the Northern Lights project? And in light of the IRA presumably prompting more of these pipelines to be built, what would your advice be?
You know, we in Northern Lights, the pipeline is a subsea pipeline going from shore and out to the storage location. We've not had any pushback on that issue at all, neither from the regulators in Norway nor from any public opposition to such pipelines.
Filip, did you?
It's very hard.
Have you come across it, Filip?
Yeah, so the Portos project is planning an onshore CO2 pipeline. This will be a collection network in the port area of Rotterdam. And it will basically extend in a CO2 line that's already there. It will be a low pressure pipeline. And I'm not aware of any major pushback against that pipeline. Perhaps also because it's inside an industrial area. It's far away from many people. So I think that has been or still is a relatively smooth process.
Thank you. And Winston, it sounded like you've done quite a lot of looking into different transport modes of CO2 from your various sites. Have you come across this?
I mean, there's always a lot of discussions whether these pipelines are needed, and of course also around the costs and the public acceptance. So far, I think the discussions are actually going in a more positive direction. But I agree. I mean, we need to be very carefully mapping the needs and make sure that these pipelines will also be required for a long period. I think one of the advantages could be to really look also into synergies with other sectors. So there will be pipelines being built, for example, for hydrogen, and why not building a CO2 pipeline right next to it? I think that will also increase the acceptance among regulators and the wider public.
Thank you. Do we have other questions? We have a gentleman here.
Thanks. Keith Birch from 7CO2. You gave us some good detail on the CapEx costs. Do you have any feeling for how that's now translating to ongoing OpEx costs for shipping and storage for potential future customers?
You're asking me, I guess. I mean, there are two cost elements here. It's the CapEx, which you saw, and that's quite transparent. As for the OpEx, it's also quite transparent. There's a white paper published actually on this by the Norwegian government showing the breakdown because part of the support from the government is actually operational support in the first years to ensure that we manage to establish a commercial business that can run without state subsidies, which is obviously the ultimate goal here, is to do away with subsidizing either on the emitter part or on the transport and storage part. The transport element is a significant element when we're looking at it today, partly because the ships are a little bit too small, to put it that way. We need to scale up the ship size. That was also mentioned by an earlier presenter talking about larger ships. I think that's a very positive direction to go in. But it ties in with the cost on the emitter side as well, because larger ships will require larger intermediate storage on the emitter side, which is also costly. And there could be significant issues with space availability on the harbors that we use. So it's a balancing act. What is the right size? Ultimately going to really large volumes, which is what we require for this to be a proper climate mitigating solution, will require pipelines as well. But I think there is always going to be a spread of solutions on the transport side. You have lower cost infrastructure with pipelines for large emitters, but the smaller emitters, it was mentioned here, for example, by Heidelberg, this facility they have on an island in Sweden. It's unrealistic to think that you'll put in a pipeline for 1.8 million tons. So shipping will be the solution. So there will be a spread of transport cost. So that's unavoidable. That's a long non-answer to your question, by the way.
Thank you. Yes, we have a lady here.
Thank you. I have a question for Winston. You mentioned in your presentation the projects that are going on in the Central Europe, in Eastern Europe, Bulgaria, Romania, Black Sea, and the date of launch is plus minus 2030. What is the timeline that you're planning? Is there any backlog that you're having right now because of the different situation on the Black Sea? And about the infrastructure, are you building it from scratch, or is there any existing infrastructure you can use for CO2 storage in that region? Thank you. Thank you.
Yes. Thank you very much for the question. I mean, so far, all the projects are kind of on time. But of course, as mentioned, I mean, it depends very much on the conditions around it, right? So we need to work on the energy side of things, because we will need to use considerable more electricity. At the same time, yes, we need to build the storage, and we also need to build the pipeline, which is, by the way, in the Bulgarian case, a very short pipeline, since the plant itself is located directly at the Black Sea. The timeline for this project, we envisage it to go online sometime around 2028, but it is a project which has started not so long time ago. So actually the storage part is something we are looking at very intensively for the time being. As I mentioned, we will use a depleted gas field under the Black Sea, and we are currently in discussions with the regulators to make sure that there's all the certification needed to do that. So discussions are very much ongoing, but the timeline envisaged is 2028.
Thank you. And there's a gentleman in the centre there.
My name is Bill Senior. I'm with Lapis Energy, and we're trying to create a funded business to develop a transport and storage business. And the timelines here are really quite challenging for investors. If we front up and say we want to do a new storage project and it's going to take 7-year lead time. And to me, that doesn't really resonate with the urgency of the problem we're trying to solve, which is keeping to 1.5 or something close to that. So I'm going to throw a challenge. So, and there's also that bearing in mind that these projects we're doing initially are the first of a kind projects. So we need to, in the same way we challenge ourselves to how we're going to reduce the costs of future projects, we're going to have to challenge how we can do them quicker, because if it's 7 years for every new project, we'll be timed out on CCS and the problem we're trying to solve. So that's the challenge for the projects, is how we're going to get that learning out there to sort of make it all happen quicker so that we can. And by the way, the project we're doing in the US, we have basically got a 4-year lead time from site identification to first injection under the US policy and regulatory framework. So there's a lot to be done to make it all happen quicker. And the question is how we're going to learn to do that. Thank you.
Thank you. That sounded like a question for you, Filip.
Yeah, so thank you for the question. I strongly agree with you that we need to speed up storage, proving up storage to the point that they can come online. As was mentioned yesterday several times already, some parts of the development can't really be compressed. You have to do the detailed design, you have to construct drill wells. In the case of aquifer storage, often everything is preceded by shooting in seismic survey, drilling an appraisal well or more. And there is not much you can do there, I'm afraid. In the middle bit, as I talked about, I think there we can may be able to win a year maybe by preparing, all of us together, preparing a workflow, a recipe that is easy, understandable, and that gives new operators the idea that they can do this too, and that it's not going to take forever and lead to unclear end times, but that there is a workflow that can be followed. And I think the same is true for the other side of the table. We really need to make sure that governments new to CCS are given the knowledge to handle these new type of projects and start to understand the type of discussions they will be having, many of them over the course of years that the projects are being developed, so that there is a meaningful and effective, efficient discussion across the table between operators and regulators. So perhaps shortening their lead time is going to be a real challenge, but I think by sharing the knowledge that's currently being developed in this neighborhood, by making sure that that knowledge is transferred, we should be able to make sure to support many new projects at the same time in parallel. So I think there's where we can win, not by shortening individual projects, but by parallelizing project development.
Excellent, thank you.
Can I add something to that?
Yes, of course.
Because storage is the most regulated non-existing business there is. And this is part of the problem. In Northern Lights, we're doing it quite differently from the timeline shown, actually, because we're challenging the regulators on that. We're not doing exploration. We're doing essentially, we're saying that exploration in our case is actually drilling of the injection well. And we're not going to provide an injection application prior to making investment decisions. We're actually going to do it in time for start of injection. So it's doing that in parallel, which is how we have cut down, I think, on our execution time and our scale up, which is going to increase the capacity from the current fairly small number of 1.5 million tons a year, which is what we're building today. The next phase, if we're successful in getting that approved, will come on stream in 2026. So then there's only a 2-year lag. So I think in addition to having parallel projects, like you're saying, we also need to be able to challenge the regulators on what they need. And we need to challenge the industry on their perception that it's a regular oil and gas business, which is what is being looked at for the storage companies, they're oil and gas companies, where development has a long cycle time. We need to cut down on that. Risk-taking is necessary to get there.
Thank you. After lunch, we've got 2 focus sessions, and you'll be able to see on the screens outside and choose which one you want to go to. But the next item on the agenda is lunch. But before that, I'd like to ask you to join me in thanking our presenters for their excellent speeches today.